Hi class, welcome back to lesson 3, which is talking about stretches, compressions, and reflections, the role of A. So far, when we're looking at our equation, y equals a x minus h squared plus k. We know that h is responsible for our horizontal shift, k for our vertical shift, and then we're going to be talking today about A, which is going to be responsible for our vertical compressions or vertical stretches. So, what you're going to know by the end of this lesson is you're going to know how to determine the value of A by looking at y equals ax minus h squared plus k, right? So it's always going to be the one in the front. You're going to know that what type of stretch it will happen, so whether or not the A value will lead to a larger stretch or a narrow. You'll know how to find the new Y values. You'll know how to combine stretches and translations. And one thing I actually forgot to add here is you will know how to graph reflections. Okay, so we're just going to get started. In general, the equation of a line is y equals ax squared minus h to minus a bracket x sorry, I'm going to start that again. You'll know that the general equation of a line is y equals a bracket x minus h squared plus k. You know that h controls a horizontal shift, so how it moves on the x-axis, right? And you'll know that k controls the vertical shift, how it moves up or down on y. Right? What A controls is kind of two different things. It tells us which direction the parabola will open up. So if A is greater than 0, which means that if you have a positive A value, right, the parabola opens up. Right? And then if you have a negative A value, the parabola actually opens down. So how I like to see this is like if you have a positive, you're in a happy mood, so the parabola kind of looks like a smile. And then if you are A is less than 0, so it's a negative mood, your parabola looks down, so it kind of looks like a frowny face, right? If your parabola is either greater than 1 or less than -1, which basically just means it's a whole number, not a decimal or a fraction, then the parabola is stretched or narrowed. So it kind of like looks skinnier. And then if you have a parabola, if you have an A value that's a fraction or a decimal, it's either less than 1 or more than -1, the parabola is compressed or widened, so it looks like it's stretched out. Okay? So we're going to be talking about stretches and compressions. Stretches occur when you have a positive, so I'm just going to highlight that. Oops. Stretches occur when you have a positive A value, right? And compressions occur when you have a negative A value. Okay? So what we're going to do is we're actually going to draw these two, or we're going to draw in this graph of y equals 2x minus 2x squared, right? So here, if we look at our A value, it's always the number that the x is being multiplied by, right? So the number outside of the bracket that the x is being multiplied by, if we look here, it's going to be our 2 value, right? So we know that A is equal to 2. So I always like to go in and have the A values. So I'm going to do both my base function because it says to compare it with base points, which we know is going to be y equals x squared. And we know that we're always going to use the same points for our base function. So -3, -2, 1, 0, 1, 2, 3. And my y's are always going to be 9, 4, 1, 0, 1, 4, 9. Right? Gonna go here and I'm gonna draw in my new function. My x's actually stay the same, so I'm gonna keep them the same here. I'm just literally copying them from over here. Right? And then we have y is equal to 2x squared, sorry. And I'm going to quickly do the math with you for this. Okay, so let's do that. So let's do 2x is negative 3 squared. You always do the exponent first, so it's going to be 2 times 9. 2 times 9 is 18. Let's do this again with negative 2. Negative 2 squared is 4, so it's going to be 2 times 4. And that's going to give me 8. Then we have 2 times negative 1. Right, so 2 times negative 1 squared is just 1, so I'm left with 2. Then we have 2 times 0 squared. 0 squared is just 0, so it's going to be 2 times 0, which is going to give us 0. And I'm just going to quickly go through it and do all of these. You'll notice that the numbers just start repeating themselves, so I'm going to go graph my base function. So I'm going to go graph the one that I did in black over here, the regular one. I'm just going to go draw it in my parabola. Okay. And then I'm going to go and draw in my pink one. So I know that negative 3 is at 18, and I don't have 18 on this graph, so I'm actually going to just go and start at negative 2. So negative 2 goes up to 8. Negative 1 goes up to 2. 0 stays at 0. 1 goes up to 2, and 2 goes up to 8. So I'm just going to draw in this graph. And you'll notice that it kind of looks like we stretched it out like on the axis and we pulled it up, so it looks kind of skinnier, right? This is what we call a vertical stretch. Vertical stretch, and that's because it's kind of thinned out, right? So it looks like we took the top and the bottom and we stretched them out along the x or the y-axis. If we look at our points, if we look over here at our y values, you'll notice that for your base function, your y values are 9, 4, 1, 0, 1, 4, 9. And if you compare them, you'll notice that from 9 to go from 9 to the new one, which is 18, 4 to 8, 1 to 2, so on and so forth, you have to just multiply by 2. Right? So let's go here. You'll notice that only the y values are being stretched. We left our x values alone. We didn't do anything new to them, right? Only the y values changed. So what happened is that they actually stretched by a factor of 2. And if we go back and we look at our a value is 2 as well. So we know that in order to get from the base function, which is the yx squared, to the new function, we leave the x's alone and then we just multiply the a's by y, right? So we do a times y, so we just take the base, which is 9, 4, 1, 0, 1, 4, 9, and we multiply those y values by 9 to get our new y values. So we're going to try doing these two. Just something to recognize here is that this is a 3 and a 4, so these are integers, whereas these are fractions, right? So these are going to be thinner and they're going to be stretches, whereas these ones over here are going to be compressions because they are fractions, okay? So I'm just going to go in here and we have our tables already made here, right? Let's start off with the 3x. So y equals, y equals 3x squared, right? We're looking for our a value. Our a value is 3, so a is going to be 3. So again, I'm going to leave my x the same because I'm not making any difference in my x, but for my y's, I am going to take whatever my y's were from my base function, right? So I'm going to go, I always write them in because I find this easier to do. So I just go in and write my base function numbers in. -3, -2, -1, 0, 1, 2, 3, right? And I'm going to take all of these y's and I'm going to multiply them by 3, which is my a value. So I'm going to do 3 times 9 and always keep them in brackets. 3 times 4, 3 times 1, 3 times 0, 3 times 1 again, 3 times 4, and then last but not least 3 times 9, right? So 3 times 9 is going to be 27, right? 3 times 4 is going to be 12. 3 times 1 is just 3, 0, 3, 12, 27. So I think 27 is just too much to graph on here. So I'm actually going to ignore my -3s. But I am, instead of going up by 1s, I'm going to go up by 2s just because I have bigger numbers here. So I'm going to go up by 2s. So I'm going to say 2, 4, 6, 8, 10, 12, 14, 16, 18, and I'll kind of get what I want to get in there. And you can always change the scale of your y. I actually encourage it, especially when we're dealing with stretches. It gets really messy otherwise. Okay. And I just keep my x's the same. I keep them going up by 1 because even my x scale was going up by 1. I'm just going to do the same thing here, -2. Right, and let's go in and put in our dots. So I'm going to leave the -3 alone, and I'm going to go -2 goes up to -12, or +12. -1 went up to, -1 goes up to 3. So it's going to be somewhere in between here. 0, 0, 1 goes up to 3, and then 2 goes up to 12. So I know that my y equals 3x. 3x graph will look something like, I'm just going to draw it in like this. Okay, and I just like to label my graph, so this is y equals 3x squared. We're going to do the same thing now, except we're going to do it with y equals 4x. So this is 4x squared. This is a good time to pause this video and think, okay, what is the a value here? It's the number that's in front of the x squared, which is going to be 4. I'm going to keep my x's the same, and I like to just write in my y's right off the bat so that I have them here ready to go. I'm going to do -3, -2, -1, 0, 1, 2, 3. I'm going to do 9, 4, 1, 0, 1, 4, 9. And my a value is 4. So if it's 4, it's going to be 4 times y. So I'm going to multiply each of these by 4. Right, so 4 times 9, I know is 36. 4 times 4 is 16. 4 times 1 is 4. 4 times 0 is still 0. 4, 16, 36. So I'm just going to go plot these points. These are my new points, -3 and 36. 36 is off the graph, so I'm going to ignore it. -2 and 16, so I'm going to go -2. I'm going to go up to 16, right? Then I know it's -1 and 4, right? So I'm going to go -1, I'm going to go up to 4. Then at 0, 0, 1 goes up to 4, and then 16, 2 is up to 16. So I'm just going to go draw in my parabola here, right? And it's slightly more shrunk. If we compare this to our original parabola, which is just our basic 0, 0, -1 and 1, right? 1 and 1, 1 and 2. Oops, sorry. Remember that this is a different scale. So then 1 and 1, so I'm just going to do it this way. -2 and 4, positive 2 and 4, and then 3 and 9, negative 3 and 9. And actually, I'm just going to put in the 4 value too, which would have been 16. If you look at it compared to your base function, which is y equals x squared, and then let's just do y equals 4x squared. I've put in all the different functions. You'll notice that the green one is the skinniest. Then you have the pink one, which is a little bit bigger than the green one, and then you have the black one, which is your base function. So while 3x squared and 4x squared are skinnier, 4x squared is skinnier than 3x squared, and that's because the bigger the integer, the more it's compressed, right? So it's just more of a stretch the bigger the number is. Okay, so moving on, we're going to go on to this one over here, which is our compressions, right? So we're just going to be graphing the compressions. And again, this is a great time to just stop what you're doing, go back, and make sure you know how to do this, okay? And so I'm going to let you stop this here. Try going through it yourself. I find it easier to turn these into decimals when I'm actually graphing, but it's up to you how you decide to do that. All right, so hopefully you pause that. First things first, let's start off with the y equals x squared. So I'm just going to change this pen to be blue. So let's do y equals 1 over 2 x squared. So a here is going to be 1 over 2. It's just the number in front of the x squared. So I'm going to do x, and then I'm going to do half times y. X's always stay the same. Right? I'm going to put in my original y values, which are 9, 4, 1, 0, 1, 4, 9. And now I'm going to multiply them by a, which is 0.5. So 0.5 times 4.9 is, 0.5 times 9 is 4.5. 0.5 times 4 is 2. 0.5 times 1 is just 0.5. 0.5 times 0 is 0. 0.5 times 1 is 0.5. 2, 4.5. So I'm going to go and sketch those in. Okay. So I notice here that my highest amount is going to be 4.5. For me, personally, I don't like graphing where I need to like have half points. Sometimes you have to do it. But for this graph, I'm actually going to scale it out a little bit more so that it's not all clumped together and it fits the page, okay? That's probably just the best form, is just try to make your graph fit the page. Because otherwise everything would, like, if I did 1, 2, 3, 4, 5, right, everything would end here. And like my graph would look like something like that. And I want to use as much as the graph Cartesian plane as I can. So let's do this. So I went up by 0.5s, right? And then I'm just going to do -1, -2, -3, -4. And then I just kept these as 1, 2, 3, 4. Okay, and let's just go put in our points. So at -3, and I'm going to do in the blue pen again. At -3, we were at 4.5, which is the highest amount. At -2, we were at 2, so I'm just going to go here. At -1, we were at 0.5, which is just here, and then 0, 0. At 1, we were at 0.5, 2, we were at 2, and then 3, we were at 0.5, 4.5, sorry. I'm just going to draw on my graph. So that's what my y equals 1/2 x squared would look like. Let's try it again. With this side now, we're just going to go over our, I'm going to make this pink. So I'll make this all pink. So it's going to be y equals 1 over 3x squared. So I like to just go in and write in, okay, these are my my x values and my y values right off the bat. So I'm just going to actually move these, make it a little cleaner. So just keep them in brackets, just easier math. 4, 9, right? And I need to go back and look at my equation of my line. So it's going to be y equals 1 over 3x squared. And if I look at this, my a value is just 1 over 3. So I'm going to do 1 over 3 times 9, which is going to give me 3. 1 over 3 times 4 is going to give me 4 over 3, which in a decimal point of view would be 1.333. 1 over 3 times 1 is going to be 1 over 3, but that's just going to be 0.33. 1 over 3 times 0 is going to be 0. 1 over 3 times 1 again is going to be 0.33. 1 over 3 times 4 is going to be 1.333. And then last but not least, 1 over 3 times 9 is going to be 3. So I got all my points, and now I just got to go put them in. So I have negative 3 is going to be at 3 now, right? That's my new point. Negative 2 is going to be at 1.33, and just try your best to put it in the best position. And then you can't here because they're going up by 5s, but just try your best to put it at 1.33. Negative 1 is going to be at 0.33, so it's going to be like here somewhere, 0, 0. Same thing on the other side. Just try your best to keep them even. And it'll look something like this. So that's going to be y equals 1 over 3x squared. Notice how because it's a fraction, it's a little bit more wider, right? It's because the denominator is bigger, so the stretch is a little bit bigger for when the fraction is smaller. Okay? And if you compare this to your base function, so 1, 2, 1, 1, negative 1, 1, 2 and 4, 2 and 4, right? Now in this situation, our base function looks skinnier, and these are thicker, so they're stretched. They're more compressed. Okay? So that's how you know when something's a compression or a stretch. When it's a compression, it's like wider, right? When it's a stretch, it's narrower. So we're going to move on, and so what we're going to be focusing on for the rest of this lesson are going to be reflections, and then reflections and stretches at the same time. And then we're going to do all of our transformations that we learned and add them all into one type of equation. Okay, so that's what we're going to be focusing on next. So we're going to start off with reflections. So hopefully we're going to move on to reflections, and we're just going to be talking about what happens when we have a negative sign. So regularly you would have y equals ax minus h plus k, right? And if you're given something like x squared, right, we just assume that the number in front of here is a positive 1, right? So if you have a positive a value, if you go back here, and you remember, it says if a is greater than 0, then it opens up. If it's less than 0, it opens down. So the only time that this really matters is when there's a negative in front of this a, or where this a value would have been. You know that you need to change the direction of opening of your parabola. So let's just go in. What you're going to do is, it's going to be the same thing. Now your a is equal to negative 1. So you're just going to multiply all your y values by negative 1. So we're going to keep our x's the same, and we're going to do negative 1 times our original y values. Right? So let's just go in, put in our values of x. Let's go put in our original y values, 9, 4, 1, 0, 1, 4, 9, right? And we're just going to multiply them by negative 1. Anything multiplied by negative 1, you just change the sign, but for the sake of clarity, I'm going to do it this way. And that dot just means I'm multiplying, right? So negative 1 times positive 9 is negative 9. I'm just going to change the sign, so it's becoming negative 1, 0, because there's no such thing as negative 0. Right, so now I have at negative 3, instead of going up to positive 9, I'm actually going down to negative 9. So negative 9. So now at negative 2, instead of going up to positive 4, I'm going down to negative 4. 0, 0 stays the same, right? Negative 1 goes to negative 1. Now at 1, I'm going to go down to negative 1. At 2, down to negative 4. And at 3, down to negative 9. And I will just have taken my function and basically flipped it. So this is my original. This is what it would normally look like, right? So I'm just going to draw on what a normal would look like. And I basically took my normal equation and I said, okay, pretend like there's a mirror on the y-axis or on the x-axis. So pretend like there's a mirror running across this line right here. I basically did that, and it's a reflection. So it reflected over into that line, right? That's what happens with the negative value. You basically take your original equation and you just flip it over the x-axis and it gives you the new one. So I'm just going to label these as always. So this is my original and this is my reflection. So y equals negative x squared. Right, so notice that only the y values are being reflected. The shape of the parabola didn't change from the positive version. When we compare the base points, the y values are just multiplied by negative 1, which is what we did. We just multiplied the y values by negative 1. Same thing, right? You just, and now you know your negative a is what it's going to be, right? So it was negative 1. So in this situation, let's graph our negative 2 and negative 1 over 4, right? So I'm going to do negative 2 in this pink. I'm going to have you try doing the 1 over 4 by yourself, right? And I'll post the solutions on how it was graphed on D2L, on Google Classroom, right? I just want you to have the chance to go through it yourself so that you can understand how that reflection component works, and then you can go and watch the video. It's very similar. I don't want to extend the video by too much. So let's do this in pink. We're going to do y equals negative 2x squared, right? And so negative 2x is going to be our a value. And since it's only a reflection, there's nothing else going on, right? We're going to go in and we're going to say, okay, let's go in and find what our x values are going to be. X values are going to stay the same always in this situation. Unless there's a horizontal shift, they're going to stay the same, right? Our y values in this situation are going to be y multiplied by whatever a is, so it's negative 2. Right, so let's just go in and write our original y values, which are 9, 4, 1, 0, 1, 4, 9. And I'm just going to go multiply negative 2. Negative 2 times 9 is just negative 18 now, right? So if we go back here and we look at our stretch, we actually did this already with positive 2. So it was negative 9 and it went to positive 18. Now it's just because it's a stretch and a flip over, right? We do it as negative 18. So then negative 2 times 4 is going to be negative 8. Negative 2 times 1 is going to be negative 2. Negative 2 times 0 is still 0. There's no negative. 0. Negative 2 times 1, negative 2. Negative 2 times 4 is negative 8. And then negative 2 times 9 is negative 18. Right, and that's what we have. So let's just go throw that into our equation, or into our graph. So I again went up by 2. So I did negative 2, negative 4, negative 6, negative 8, 10, 14, 16, 18. Same thing, just going 2, 4, 6, 8, 10, 12, 16. So sorry, 14, 16, 18. And then I went up by 1s. Right? And I'm just going to go put in my things. I'm going to say, okay, negative 3 goes up to negative 18. So I'm going to go draw that in. Negative 8 is at negative 2. So we're going to go negative 2, negative 8. Negative 1 goes to -2, and then 0, 0. Same thing on the other side, right? So my parabola looks something like this. So I can just do vertical stretches and reflections at the same time, right? And normally my graph would look something like 0, 0, -1, 2 would go up to 4, 3 would go up to 9, so just right here. All right, so it looks something like this normally. So you'll notice that this graph is thinner and it's reflected over the axis. Okay, so you try with the 1/4. So I'm just going to highlight this in green. Right, the thing to note here is that your a value is -1/4. Right, so similar to what we already did with -1/2, you're going to do 0.25 times the y values. Right, and then you're going to keep the same x's. And you're just going to go in and plot it. So try that one on your own. Now we're going to move on and we're going to talk about graphing all our transformations together, right? So when we graph all of our transformations, if you're going to graph using multiple, you'd have to go in, then you'd first have to go put in your x coordinate, then you'd have to change your y coordinate, and then you'd have to stretch all of it out. You'd have to do that 3 or 4 times. It's just easier to use this combination of transformations formula, which is the x turns into x plus h, and then the y turns into a y plus k, right? So then what we do is we take our base formula, which we always know is going to be -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, you know, the original equation that we have, and just use this transformation table in order to graph our y values. So we can graph, I was going to do this one, but I'm actually going to do the 2 that it says to graph here. It's going to say graph y equals -3x plus 1 squared plus 4, right? So we're going to do those 2 as our transformation tables because in the end we're actually going to compare them both to each other. Okay, so I'm going to go in and I'm going to say, okay, what's my original points? So I'm going to just point in my original formula and my base function. So our base function is going to be y equals x squared, right? And I'm just going to go in and write down what my formula for that is. Or sorry, my table of values is. So x, y. We start off -3, 2, 1, and then 1, 2, 3. And then we know it's 9, 4, 1. This always stays the same. Right, so that's my y equals x squared. So let's just go in and graph that. So I think for this one, I actually went up by 1s because I found it easier to do. And then I just took, for the 3, I just kind of got rid of some of them. So it is what it is, but that's fine. 5, 6, 7, 8, 9. All right, and now that I have my grid there, let's go put in our dots. So -3 goes up to 9. -2 goes up to 4. 1, 0, 2 goes up to 4. 3 goes up to 9. So I'm just going to draw in my base function, which is y equals x squared. Right. Then we're going to go in and we're going to find our new dots. So first things first, let's figure out what let's do this one in this pink color. So I'm just going to highlight it. So let's find out what for y equals -3x plus 1 squared plus 4. We want to find out from formula a x minus h squared plus k. Let's find out what our a value is. So I like to always go and write everything in so that I remember. So it's going to be -3 is my a value. My h value is -1 because it's the opposite of this one in here. And then my k value, k value is going to be +4. Okay? So here what I'm going to do is I'm going to say I'm going from xy to my x is going to be x plus h. So if I go here, it says x plus h. And then my y value is going to be ay plus k. Right? So let's just go put in these placeholders for now. X plus h, ay plus k. Right? I'm going to put in the x's I already know. -3, -2, -1, 0, 1, 2, 3. Same thing with the y's I already know. My y's are going to be 9, 4, 1, 0, 1, 4, 9. And I just took these from here, this base function over here. Okay? Now, let's go find out what my h was. It was -1. So I'm going to do x plus -1, which is going to be -1. Which means for all of these x's, I'm going to do -1, -1, -1, -1, -1, -1, -1. Okay, let's do that math. -3 minus 1, -4, -2 minus 1, -3, -2, 0 minus 1, -1, 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2. Those are my new x values. So I like to just draw out a second table for myself so that I know drawing is easier, but you don't have to do that. 3, -2, -1, 0, 1, 2. Those are going to be any new x values. Let's find our new y values. I'm going to replace the a with the a that I have here, which is -3. And the k that I had here, which was 4. So it's going to be -3y plus 4. So let's just go plug in -3y plus 4. -3 times 9 is going to give me 36 plus 4 is going to give me -23. Sorry, -3 is 27. Plus 4 is going to give me -23. -3 times 4 plus 4, I just like to throw that into my calculator. It becomes -8. -3 times 1 plus 4 becomes +1. -3 times 0 plus 4 becomes +4. -3 times 1 plus 4 becomes +1. -3 times 4 plus 4 is going to become -8. -3 times 9 plus 4, again, going to be -23. So I like to go here and put in my points. So it's going to be -4 at 23, but that's my new y value. -3 at -8, -2 at 1, -1 at 4, 0, 1, 1, -8, and then last but not least, 2, -23. And now I'm going to use this table to graph my function. Right, so I'm just going to carry it over here so that I have it for reference as I'm doing my chart. And then I'll move it back. So let's do that. So I have -4 right at -23. Isn't on the chart, so I'm just going to leave it. Then I have -3 at -8, which I have on my graph, so I'm going to put it there. -2 at +1, so I'm going to go -2, +1, and then -1 goes all the way up to 4, right? Then I have 0, which comes down to 1. Then I have 1 that comes down to -8, and then again the 23 is off the chart, so I'm just going to leave it. Right, I'm going to make my graph. That's going to be my green one, and that green represents the y equals -3x plus 1 squared plus 4. Now, if you did this, where you went in and you found, you use different x values and you tried to find the different x values, it would take you so long to do, right? Because then your graph would be all wonky and then it wouldn't be a fun time for anyone. So the reason I recommend using this way is because it just makes it easier for you to combine those functions together. So I'm just going to go in and draw this back here. Okay, and then, so that's our new function. And we'll fill out the chart after. I would like to draw them in different, I'm just going to change this so that I realize that I drew this in green instead of pink. So let's change this back to green. Okay, and I'm just going to change this to green as well. So now let's draw our next one. We'll draw this one in pink, right? So we're going to do negative y equals positive 1 over 2, x plus 2 squared plus 1. So let's go and find our different values. So it's going to be a is equal to just the number in the front. So it's going to be positive 1 over 2. H is equal to positive 2, and it's going to be the opposite because we're pulling it out of the bracket. And then k is equal to positive 1. It's outside the bracket, so we don't have to change any signs. Okay, so we have that situation. Let's go plug it into our formula here, right? We know we have x, so let's just draw in our x's, our original ones, right? Let's draw in our original y's. 9, 4, 1, 0, 1, 4, and 9. And then let's go write in our equation. So I know it's going to be x plus h, right? And that's just from up here. X plus h, ay plus k. Let's go replace what we know. We know that h is going to be negative 2. So it's going to be x minus 2. And then we know that a is going to be 1/2. So I like to write it as 1/2. And then k is going to be positive 1. So we're going to leave it as positive 1. Let's go put in what we know. Let's just go write these in. So I'm going to put a negative 2 to change all my x's. Right? So negative 3 minus negative 2, negative 5, negative 4. Negative 1 minus 2 is going to be negative 3. 0, 1. Right? Those are my new x values. So I just like to go draw on a separate chart for myself so that I can use it after. So negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. Let's see what we can do here. So then I'm going to have half times 9 plus 1, right? So let's do that. 0.5 times 9 plus 1 is going to be 5.5. Half times 4 plus 1 is going to be 0.5 times 4 is 2 plus 1 is 3, right? Half times 1 is just going to be 0.5 times 1 plus 1 is going to be 1.5, right? Then we have half times 0, which is just 0, plus 1 is going to be 1. And then it starts to repeat, so 1/2 times 1 plus 1 is 1.5. 1/2 times 4 plus 1 is going to be 2.3, sorry, oops. And then 1/2 plus times 9 plus 1 is going to be 5.5. So those are my new y values. So I'm just going to go write that in. 5.5, 3, 1.5, 1, 1.5, 3, 5.5. Now I have a new x and y table that I can just go plot in. So I'm going to say, okay, I'm going to go to negative 5, go up to 5.5, and it'll be in the middle because we were going up by ones. Negative 4 is going to go up to 3. And I like to just keep my table open in front of me. I'm going to avoid jumping back and forth just to save you from that glitch. But then we have negative 3 and we go up to 1.5. Negative 2 goes up to 1, right? Then we have negative 1 goes up to 1.5 again. Then we have 0, which goes up to 3. And then last but not least, 1 goes up to 5.5. So my graph looks something like this, right? So that's going to be y equals x minus, or 1/2 x plus 2 squared plus 1. And if you notice here, we shifted over by 2 and up by 1, and then there's a stretch as well. Okay? So if we look at our graph here, right, it says to just do a summary. So for the vertex, let's look at x, our basic function. We know our vertex is just this point right here where it changes around, so it's 0, 0. Let's look at the vertex for -3, x plus 1, and 4. So we know the vertex is always h and k, right? So let's go find out. It should be, in theory, -1, because that's what our h was, and +4. So I'm going to write it in, but I also want you to see how you can see it on your graph. If you go here, -1 and 4, that's our vertex right there, and you can see it. And I'm just going to change this to the color that that graph is, HK. So -1 and 4. And then if we look at our pink graph here, right, in theory it should be -2 because that's what our h value was, and 1, right? So I'm going to write it in, but I'm going to show you also how you can see it on the graph. -2 and 1, that's our h value, our vertex. Axis of symmetry is just where the graph turns around. So it's just the x value of the vertex, so it's just h. So I always write axis of symmetry is equal to x equals h. So whatever the h is, here the h is 0, here the h is -1, and here the h is -2. So those are axes of symmetry. Is it a stretch or a compression? None, right? Because this is our base function. This one is a stretch because its number a is big. A is greater than 1, right? Here, a is less than 1, so it's a compression. Direction of opening, the standard one just opens up, right? For this one, there's a -a value, therefore down, right? Which makes sense. If you look at the green graph, it opens down. Here we have a +a value, therefore up, right? And if you look at the pink graph, it opens up. Maximum or minimum, if something opens up, there's always a minimum. If something opens down, there's always a maximum. And again, if something opens up, there's always a minimum. And that is it. That is the end of this lesson. This was a lot, so for sure, stop, pause, do the practice problems. They will definitely help you understand how we found these answers.